Okay, hello, welcome to my channel. My name is Ansh, and in this video we're going to solve this problem right here. So we are given that this infinite series on the left hand side converges, and it converges to 5. Good. So we want to find out what the value of cosine of 2 times of theta is. Okay, so I'm just going to start off with a solution. Now you notice from the information, we don't need to worry about the angle theta because we are given that this infinite series converges. So that means theta is nice enough. Okay, great. So maybe let's just think about cosine of 2 times of theta. So using this tool, we know it's a trigonometric identity, of course, a well-known fact that cosine of 2 times of theta can be written in this form. So maybe just to derive that, you can use the cosine identity for sum of 2 angles. Now when the 2 angles you are adding are the same, like theta, when you add theta to itself, that is cosine of doubled an angle. Good. This can be written as that. So maybe let's just spell it out here. Cosine of 2 times of theta. Well, we can write this as cosine square of theta minus sine square of theta. Okay, great. Well, we're going to use the fact that sine square of an angle is 1 minus cosine square of that same angle. That'll be 1 minus cosine square of that same angle to rewrite this sine square, right? So this negative is out here, and then we put the cosine square of theta like that. Okay, so opening up this bracket, the negative will meet with this. This will become positive cosine square of theta as well. Adding them up, that will be 2 times of cosine square of theta. And then the minus 1 is out here. That is another way of writing, another way of writing cosine of 2 times of theta, which we have here as the tool. Good. Okay, so let me just clean this off right here. That's nice. Then the next thing we'll do is to think about the series we're given. So we have the sum, okay, as n starts from 0 up to infinity. Well, let's just expand the sum. Okay, so when n is 0, 2 times of n, that is 2 times 0 is 0, cosine of theta raised to the power of 0. Well, that would be a trouble if cosine of theta is 0. But again, we don't need to worry about it, so I'm just going to put here 1. Well, we add that with, well, when n gets to 1, that will be cosine square of theta. When n is 2, sorry, we're going to add it with cosine to the 4th power of theta, and so on and so forth. Maybe let's get to the some k term. So that will be cosine of, well, that will be the k plus first term. That will be that will be cosine of 2k of theta. Yeah, and then we're just going to keep on adding because there are infinitely many terms to be added. Good. Okay, but you notice that if you can notice this right here, the first number we're adding here is just 1. Okay, the next term is gotten as cosine square of theta. The next one, cosine to the 4th power of theta. Maybe the next one will be cosine to the 6th power of theta. So that is to say the powers of the cosine increase in each term by 2. Okay, or another way of thinking about it is that if you multiply the first term by cosine square of theta, we get the second term. Multiply the second term by cosine square of theta, we get the third term, and so on and so forth. So that tells us that this right here is a geometric series where the first term is 1, and then the common ratio is cosine square of theta. Good. And since the series is infinite and it converges, we are going to use the sum of finding infinite terms of a GP, which we can spell it out real quick as this sum, okay, is going to be, well, that will be the first term divided by 1 minus the common ratio. Well, in this case, the absolute value of the common ratio, where the absolute value of the common ratio has to be less than 1 for the series to work. Good. So in our own case, we know we don't need to worry about it because we are given that it works and it is equals to 5. I'm just going to substitute each of these anyway. So this is the sum is, well, in our case, we have the first term as 1. We divide that by 1 minus r, where the r here is cosine square of theta. Good. So in this case, cosine square of theta has to be less than 1. Well, I don't worry about the absolute values because cosine square is always non-negative. Good. But again, this holds even from the question. Okay, so we notice that since this sum is equals to 5, I'm going to equate this ratio to 5. That means we're going to have 1 over 1 minus cosine square of theta. Okay, we're going to have this to be 5 on the right hand side. I'm going to try to solve for the cosine square of theta. So maybe we can do that. And then on the way, we're going to get this out. That is by taking the reciprocal of both sides. And then the next thing I would like to do is to subtract 1 from both sides and then multiply through by negative 1. Okay, so in that case, we're going to have cosine square of theta to be, well, let's see. When we subtract 1 from both sides, it will be negative 4 over 5. And then we multiply both sides by -1, that will be positive 4 over 5. Good. Okay, so we have this out. So what next? Well, I'm going to notice what we want. So since we want to find out what the value of cosine of 2 theta is, maybe we can as well just put it in this form. So the first thing I'll do is to multiply both sides by 2 and then subtract 1 from both sides. So I'm going to multiply both sides by 2. So I'm going to multiply this. Let me write it well. So I'm going to multiply this by 2. And then I'm going to also subtract 1 from both sides. So I'm going to subtract 1 from the left hand side and I also subtract 1 from the right hand side so that we can get this expression, which is exactly what we want. Good. Okay, so you notice that on the left hand side we're going to have 2 times cosine square of theta minus 1, which is on the right hand side, well, this is 8 over 5 minus 1. Well, that is just 3 over 5. Good. So that tells us that the value of maybe cosine of 2 theta, which we can again rewrite it as this from the tool right here, is just 3 over 5. And that's exactly what we wanted. Okay, great. All right. I hope you enjoyed the video. Please don't forget to subscribe to my channel, share the video with your friends, and we'll continue from my next video.